Welcome. Today we'll be constructing a parallel circuit. You may ask, what is a parallel circuit? A parallel circuit is one that allows current to flow in multiple directions. For example, in our homes, the power company sends the electricity to our homes and then it's divided up into different sections of our homes through the circuit breakers. Now to construct this circuit, here are the materials and supplies that are needed. We have our conductors, our tools, which we'll be using linesman pliers, flathead screwdriver, and my favorite, long nose pliers. We have our switch, single pole switch, our lamps, and our wire connectors. And also power cord for our energy source. Now let's begin. First, before we begin, remember, safety is paramount. Please practice all the safety precautions when dealing with electricity, okay? Now, I like to place my devices on the board, location where they'll be wired. So I'll set up my lamp holders at the top by the octagonal boxes which are designed to house lamps. And our square boxes which you use as the pull boxes, and our rectangular boxes we use to house our switch. Okay, let's begin with our first conductor, which is this white wire. This is called the neutral wire. Now run it from the rectangular box all the way through to the top to where light will be connected. Now remember, this is a parallel circuit, so there will be one source coming in and then it will be divided up among the lamps. Let's get our tool. Measure twice, cut once. You don't want to waste any materials. Now as you can see, on our lamp holders it has two wires, conductors, red and white. Now we're going to follow all the color codes and just connect the color wires to the colors that are on the lamp holder. Now I said the white represent what again? Correct, the neutral wire. And the red is called our switch leg. This is where the current comes in from our switch to the lamps. So we use linesman pliers, which is a combination pliers. You could use to twist, cut, and also strip. So you're going to expose about 1 inch of the conductor by stripping away the insulation from the wires. We're going to do that for all the wires here. Now you realize when I'm stripping, right? I'm stripping away from me. So the excessive conductor, see, goes in front, not to my face. Okay, now we're going to run our wires through conduit boxes where our lamps are located. This one is where the main source comes in. Now we're going to do a twist joint connecting all these conductors together, including the one from the lamp as well. Hold these tightly. Use use our tool, twist, release. Now this takes practice. Take our Y nut, secure the connection. That's one there. Take our other lamp, do the same procedure. Should they lock tightly? Here we have it. Now that we have connected our neutral wire, now we're going to connect the red wire, which is the switch leg. Now remember I said about the switch leg, right? It's connected from device to the switch. That's why it's called a switch leg. Now same procedure, running through the conduits, then to our lamps. Now you might ask, why am I using so many different color wires? Easy. So I could easily trace and see where all my wires are connected, or in case there's a mistake on the board, we could easily trace to find where the mistake lies. Or if someone else comes along, and if the electrician who did the job is not around, so another electrician could come around and he could follow all the steps and find whatever problem it is and correct it. Now imagine if all these wires were white or red or black, how hard that would be to find that mistake. So that's why all the wires have a different color, and it's color coded when you do the job. So we're going to strip the ends of these wires. Making our twist joint again. Fire a wire nut. go. Now this is the same procedure the electrician has to go through when installing these fixtures. Well, the difference is he'll be working in the roof, the ceiling. Remember, every connection you make sure you check it twice to make sure it's properly connected. Because in electrical, sometimes you feel your mistake. It's getting shocked. So to avoid that, make sure all your connections are tight, well secure. Okay, now for a switch. Now, in our switch we have screw terminals, okay? So make a hook on the wire. What wire is this again? A switch leg. Connect terminal, screwdriver. Tighten. Do the same thing for the black wire, which goes to the power source. This is called our hot wire. This is where the current comes in first through a switch and to our lamps. So make a hook, long hole splice, and hook it to the terminal. Now, there are two methods of connecting your wires to your switch. You could either use the terminals, or it has two slots at the bottom. You can strip the wire and insert them into the slots at the bottom and they'll be secure just like the terminal. But I like using the terminals. Okay, now this is where the fun part begins. Now before we connect to our source, I just want to run through again to make sure that everything is connected properly and ready to go. Okay, so check my connections once more. Make sure they're securely tightened to the devices. Now, what's the next step? Of course, our lamps. Wire for our power source. Make sure the switch is off. Plug it in. Now let's see if I did a good job. There you go. All three lamps are on. Now, what type of circuit we said this was? A parallel circuit. What's a parallel circuit? One that allows current to flow in multiple directions. Now, let's test to see if this was done correctly. Let's turn off our switch. Now, if I unscrew bulb number 1, what will happen to bulb number 2 and bulb number 3? A, they'll all be off. B, they'll cut on. Let's see. If you said B, you're correct. They will stay on because it has multiple pathways for current to flow. Now let's put in bulb number 1 back in. It's a little hot, so I'm still going to try, okay? Let's say we unscrew bulb number 3. Didn't affect bulb number 1 or bulb number 2. Although current is flowing from the switch, which is one pathway, and to the lamps. When it reaches here, it does what? It splits up. So some went this way, here, and there. Let's try bulb number 2. Let's unscrew bulb number 1 and see what happens. Bulb number 3 stays on because it's getting its own supply from the line that comes in. Now there you have it, our parallel circuits. Now you could check in your homes to see what lights are connected in parallel. You could check the ones in your hallway, in your dining room if you have more than one light there, or the kitchen if you have multiple lights there, and see if you have a parallel circuit or a series circuit. Thanks for watching. Come again.